Okay, so we're talking about triangles, proving triangles congruent again. Last time we talked about a shortcut way of proving two triangles are congruent using SSS, which is three sides of triangles congruent. And then we also use SAS, which is the side angle side, where two sides and the one included angle are being congruent. So this today we're going to continue with the shortcut of uh, proving two triangles are congruent, and we're going to add two more shortcut ways. So this time it's ASA, which is angle side angle, and then angle angle side AAS, right? And so this is a little bit more tricky, but again, these are shortcuts, ways of showing just three corresponding parts instead of showing all six, right? So that's what we're going to do today. So here's another postulate, the ASA, the angle side angle congruence postulate. So this is kind of like backwards of the side angle side. So we know two angles here, and then the side is in the middle of the two angles. So that's the included side. Last time we had an included angle in the middle between the two sides. So this is kind of backwards. Now we have the side in the middle between the two angles that we're looking at. So if you look at the picture here, angle A is congruent to D, angle C is congruent to F. So we have two angles congruent to two angles in the other triangle. And then the side in between the two angles, that's the included side, is congruent also. So in that case, the angle side angle shows that these two triangles are congruent. Now notice the important thing here is the location of that side has to be between the two angles, right? So it's not about the AB, it's not about the side BC, but it's about AC, which is between the two angles A and C, right? Same thing here. It's between the angle D and F. And so those two included sides between the two angles that are congruent must be congruent also in order for the angle side angle to work, all right? So that's the other shortcut way. Now, another way, this is a theorem now, so we can actually try to prove this, but we're not going to spend time to prove it, but we're just going to use it. So this is the angle side. Now, notice here, the angle is next to each other, and the side is separate. So it's not between the two angles, but it's away from the two angles. So that's what we call the non-included side. So that means the side is not in the middle, but it's on the other side, that not in the middle. So here's the angle, and then notice the side is not between the two angles, but it's the other angle. So it could have been AB as well, congruent to DE, but either one of these would work. So that would be the angle side, congruent to the angle side. So you can use both angle side angle and angle side. So what that means is basically when you have two angles congruent to two angles of another triangle, you just need to show one more side that's congruent. It doesn't matter where they are. If it's in the middle of the two angles, that would be angle side angle. If it's not in the middle, whether it's here or on the other side, it doesn't matter. Both will work. That would be the angle side. So as long as two angles are congruent to two angles on the other triangle, you just need to show one more side. It doesn't matter which one because they will all work, whether you're using angle side or angle side angle, right? So that's a theorem, the angle side congruence theorem, all right? So let's take a look at some examples of how we use that. So we have a picture here. Now, again, these two angles here are right angles, so they're congruent. And we don't know anything about any other angles. Now, we do know this side here that's overlapping, that's congruent to itself. So we have one side and one angle congruent to one side and one angle for the other triangle. Now, we need one more information, right? Whether it's the angle, whether it's the side, but we don't have that here. So this is not enough information, right? We only know two things. We need to know three things in order to use either SSS or SAS or ASA or AAS, right? Those are the four that we just looked at, right? Two from last time and two from this time. right? But none of them will work if you only have two information, right? Now this one, we have two angles here and here congruent to two angles here and here for the other triangle. And again, these are overlapping, so the middle side is going to be congruent to itself by reflexive property of congruence. So that means the included side is in the middle of the two angles. So this is the angle, side, angle, congruent to the other triangle here, angle, side, angle. So these two triangles are congruent by angle, side, angle, congruence postulate. Okay, so you have to make sure the location of the congruent angles and the congruent sides, and you have to sort of follow the order through the triangle to see whether it's ASA or AAS or side angle side or SSS. Okay, so those are the four that you can use up to this point. There's more, but the four that we can use for now. So this is just the kind of a written explanation of what I just talked about. Okay. So here, if I have these two triangles here, how can I show or prove that the two triangles here are congruent based on the information that's given to you here? So these two sides are parallel, right? That's the parallel symbol. And it's also indicated by the arrow or the triangle here. That means these two sides are parallel, right? And then so we have parallel sides, and then this is the transversal that you can use. And then you have the alternate interior angles that are going to be congruent, right? And then we're given that the angle y here is congruent to angle x. So that's already marked here for you. Right? So we just have to kind of write down all the information here, starting with the given information. So we're given that the angle y is congruent to angle x. That's given to us. And then we're given that the segment WY is parallel to segment XC. So that's already indicated on the picture with the little arrow here or the triangle, however you want to say that, right? So then given the two parallel lines here, and that's the transversal, using the alternate interior angle theorem, right? So these are parallel lines, these are transversal, which means that this interior angle here is going to be congruent to that alternate interior angle there, right? So then this angle here is the angle y, w, z, that's this angle here. And then that's congruent to this angle, which is angle x, z, w. That's this angle here, right? And that those two angles are congruent because they're the alternate interior angles, right? So there's two parallel lines here, and then this is a transversal. That's the alternate interior angles theorem that tells you those are congruent, right? Now, we also know that since these two triangles overlap here, this is going to be congruent to itself. So that's the reflexive property. So that's the segment WZ is congruent to itself, segment WZ, and then I already marked it, right? So then here you can tell that the WY, the angle Y and this angle here, YWZ, is congruent. So that's the angle. And then this is the common side for both triangles. So if you kind of go through the triangle in order, this is angle, side is congruent to this angle and this side. Actually, let me mark it with two arcs here to differentiate between the one arc here, right? And so that's the angle side theorem that we just looked at, right? So those two triangles are congruent by angle, side, because this side is not between the two angles, but it's the non-included angle, which means it's not in the middle, but it's another one here. So that's the angle side congruence theorem. So the two triangles that we're trying to prove is the triangle WYZ is congruent to triangle ZXW. And we prove that because we indicated the two angles that are congruent, and then this side that's congruent, making it angle, side, congruent to angle, side. Okay? All right. So then we have another theorem here, proof here. So we're given these two pictures, and we're given that R is the midpoint of segment QS. So R is the middle of segment QS. So I wrote that first. I just copied the given information. And this is the midpoint that we looked at already, right? Whenever you have a midpoint, that means it's going to bisect the segment in the middle. That means you're going to get two congruent segments here. So this segment and that segment is going to be exactly the same because R is going to be in the middle of the whole thing. So then segment QR is congruent to segment SR, right? And that's the definition of a midpoint. So as soon as you hear a midpoint or see midpoint, you can get those congruent segments, right? That's the definition of midpoint. Now we're also given, I just copied this down here, the angle QRP is congruent to angle SRT. I just copy that. And then I copy angle Q and angle S are right angles. So I just copy the given information. Now, so I marked here angle QRP here is congruent to angle SRT. So it's already marked here. So those are congruent, and I just wrote it down. Now, the fact that the angle Q and angle S are both right angles, it's kind of obvious. They're both right angles, which means that they're both congruent as well, right? So I just wrote angle Q is congruent to angle S, kind of obvious because they're both right angles. And so that's the right angle congruence theorem, which basically says that all right angles are congruent to itself, right? So all right angles are congruent, kind of obvious, right? So then if you look at the picture, I have the angle, side, angle, congruent to angle, side, angle. So therefore, the two triangles are congruent by ASA congruence postulate. Okay, so that's how you can use the ASA or AAS, similar to how we use the SSS and SAS. So I know we got a lot of letters here, but don't get those letters confused. But you can use all four of them now, right? Okay, so that's just the explanation of what we just did. So that's the homework and using. So now you could use four shortcuts. You can use SSS, SAS from last time, and you could also use the ASA and AAS from this time. All right, so you have more tools, more shortcuts, way of showing two triangles are congruent. All right, thank you.